So weird. Oh my god. I look so sleep deprived, to be honest, but I'm not actually sleepy. What? Why do I feel look so sleep deprived? I'm not. Anyways, here guys, I'm preparing for chemistry board exam. Sorry, not board exam. Chemistry. Um, trying my best to read as much as possible. Doubles for an increase of 10. You know what? Let me just look up for this. 1 minute. So, the rate of the chemical reaction doubles for an increase of 10 kelvins in absolute temperature from 298 Kelvin. Calculate activation energy. Let's check. I know, this is gonna be crazy, and we are not gonna give it. So I'm gonna keep it from this side. It looks much better for some reason. There is a light source. Let me just lower this down because there is some reflection coming up. I don't know why. So yeah, that's fine. That's a good bright source right here at the back. I look so weird, man. Do I? Yes. Okay, so technically, two weight doubles. Weight doubles, that's why two. So K2 by K net, but that does that explain it? Okay. So you're telling me that weight doubles means it's just 298 to 300? Okay, that is pretty weird to be honest. You try to find it with the help of the formula of temperature coefficient. Because there's a formula that I want to learn. Oh, hi there, guys. There are already 5 viewers watching me, man. That's crazy. That's crazy, bro. There are already 5 viewers watching me. This is the power of mobile streaming. Now it's 15. Whoa. 10 viewers added. No, this is the power of mobile streaming. Usually I do laptop streaming, but now I'm doing mobile. Just to check and interact with the people. Hey there, guys. Now it's 21 views. Hi. Nice accent. Are you from the US? No, I'm not from the US. Actually, I'm Indian. Yeah, my bad. Some people are like, yes, you have a great accent, bro. If I switch to my normal accent, it would be like, hey there, how are you, man? Hi, how's your day? Crazy. No, I'm not from US. I'm Indian. Victor 452, how are you doing? Yo, S Noxilo, how are you doing, man? It's going great. Tomorrow is my chemistry exam, and I'm practicing chemistry. For those who don't know what I'm doing a 75 ultra hard challenge, and today it is day 53 of 75 ultra hard challenge. For those who have been watching my series, yesterday I did not stream. Karnataka, India. I live in Karnataka, and yeah, for those who were telling me where I didn't stream yesterday, yes, I was off streaming. I did off stream studying, which means that I was completing full chemistry, and I was successful with that. I just need to read textbook and practice some questions now, like from the last chapter. That's it. So I'm doing that. And nice to meet you guys. This was so fast, by the way. I didn't expect 5 viewers that early, to be honest. So yeah, nice to meet you guys, and thanks for liking my stream. I just saw someone liking it. So yeah, mu is equal to kt plus 10. Okay, divided by kt. With this, we know that should be it is doubled for an increase in 10 Kelvin in absolute temperature. So I know, guys. I know it's pretty weird. When your guys are asking me, you may have no idea of what I'm saying right now, but Trust me, this challenge is very difficult, man. But yes, it has given me a lot of self improvement. If you look at my previous live streams, you'll get to know why. I have completed for okay chemistry, right? Yes, I'm practicing chemistry because tomorrow is chemistry exam. Right now it's 11:40 a.m. Practicing numericals. 2.303 RT square log mu, which has a higher negative electron gain enthalpy. Fluorine or chlorine? Fluorine. Yeah, I'll try. If I'm wrong, then yeah, maybe my bad. Okay, should be fluorine. Chlorine, buddy. Okay, let me check. Let's see. Which has higher? Okay, I'm in 12th by the way, so I kind of forgot about the concept, but let me just check. But hey, you're in 11th, I guess. Nice. Let me just check. I don't know, but I remember studying fluorine. Is it? 1 minute. Something is wrong, guys. 1 minute. It should be fluorine though. I don't know how. It's chlorine. Gain enthalpy. I think it's fluorine, but let's check. It should be fluorine, right? Sorry. I mean F or Cl. Let's see. Yeah, so it says I graduated, gang. So yeah, it's given here. You can check. 1 minute. Yeah, the oh my god, reflection. My bad. I think you guys can see it says electron. Is it inverted? It says, oh man. Man, I don't know if it is inverted or not, and it's a bit blurry too. My bad. Thank you, man. Thank you. And sorry, guys. I'm a bit. No, I'm not actually. I didn't even do a NEET exam because I'm a 12th standard student. I'm preparing for boards in fact. So I'm just I just graduated 11th standard. After it has been 2 months. Sorry, guys. 1 minute. I'm a bit busy. 314 r t square t square. Well, you guys can say if you want to t square. And yeah, there's a one person watching me. Also, nice meeting you and S Noxidal. T square. What is t square again? It is 28 square. So it's 10 square according to this. Log mu, which is log 2. EA is equal to 2.303. If I use my log, what will that be? 0.3674. A minute. Technically, our so they told me that the derivations are gonna actually be used for calculation purposes if you don't know what the zero order or first order reaction is. But I'm not sure about the main whole idea. Like teacher didn't say about the whole thing that you have to derive and study this. She said that it would be only effective if you forgot about it. So it's not needed, but it's better to prepare for it. Who knows if anyone asks a question from it. But yeah, teacher said like it's not that needed. But on the safe side, on being a safe side, you should like like go through it. It's very important, according to me. That's my suggestion. Also, it's pretty easy to learn those derivations, so you can complete them in just like 10 to 20 minutes. Trust me. Just don't take too much time. Okay, sorry guys. My bad. Some people needed some help, so I was just helping them out. Yeah. So where was I? 0.3674. Looks like now we don't have any viewers. Oh, thank you for the 3 likes, by the way. That's great. Mm, 2336 1 23623 6989 sorry, and 9698 set. Yeah, so 969683. Yep. Okay. हाँ. बोलो बेटा 12 घंटे. रुको इसको. हाँ. Also, I'm live. Okay, so I'm gonna actually have a short stream right now because I have to also sleep early, but I'll try not to actually like do that. But okay. So there's one such questions which you need to try out. Another ones. These are these types. Now these ones are a bit too complex, but we'll try. So table ones, yeah. Oh yeah, this one, right? So we have these types. Now I'm technically a bit too scared about this one, but we'll try. We are not going to give up. 2N2O5. Okay, so we got 2N2O4 plus O2 gaseous state. Yes. Serial number, this is times in second, and this is total pressure in ATM. This is 0, this is 100, this is 0.5, this is 0.512. This is 1, this is 2. Now this, I will take this reaction again. 2N2O4 plus O2 gaseous. That looks so interesting. Okay, so what I'm gonna do with this is that I can actually like take this and decompose it. So gas. So that makes sense. So this is 0. This will be no. This is not 0. My bad. What's the total one? Let's say this is 0.5, and this is 0. This is 0. If I take this as 0.5 minus 2x, then this is 2x, this is x. So if I try to take the total, this will be 0.5 minus 2x plus 2x plus x, which will be 0.5 minus this gets cut off, this gets cut off, so this is plus x. That's one thing I get. So x is technically pt minus 0.5. pt, okay. Oh, we formed 2 equations here. Okay. This is a bit too complex too, because this is based on the timings of pressure instead of concentration, so it will take some time. Yeah, well, Then we have this. We'll try this one as well. With this, we'll get some idea of what we're doing. Okay. Just remember that ft 3 by 4 is given, so that will be 3 r naught by 4k. The reason why I said this is because here it shows that this much was being used, so 1 by 4 r naught, and that 1 by 4 r naught is subtracted, so that much amount of thing is remaining, and based on that we get this much. So 3 r naught by 4k, that is one such idea as we could get from this. And yeah, technically that's a great idea, which means this is very interesting, because usually I would forget what I'm doing. So if I try 3 1 by 4, I will get r naught by 4k. It's John Master, Micah. Okay. Hi there, Aaron Yeager TD3BZ. To be honest, I didn't understand what you tried to comment. If you could exaggerate or explain it at the same time, then I would get the idea. Okay. So, I look so weird in this. Okay, 8 viewers are watching me. Damn, I did not notice that. Wait, where was I again? X is equal to pt minus 0.5, and from here, no wait, I didn't get what Aaron Yeager said, but shout out to Aaron Yeager. Looking at my list. Okay, nice. That wasn't the topic I was going for. Okay, but let's see. So you're telling me that I got this alright, and I took it as well. pt minus 0.25 minus 2x, which is x is equal to pt minus 0.5, which I finally found it from this value. So pt is equal to pn2o5 plus pn0204 plus pn02. So something like this, which is pretty interesting. How am I gonna do this now? Wait, oops, my bad. So pt is equal to one minute, and we know that this is the one. So pt is equal to 0.5 plus x. So if we try to apply this is pt is equal to 0.5. No, don't do that. So we can just like apply this instead of that. It is actually 0. Okay. So you're telling me that pn2o5 will be 0.5 minus 2x, and pn2o5 will be, okay, this is a bit too confusing, but okay, 0.5 minus 2 into 0.5 plus x, into 0.5 minus 1 plus 2x, and that is 0.5 minus 0.5 plus 2x is equal to pn2o5, which is technically equal to 0.5 plus 2x. Okay, wait. So I'm a bit confused here, because this is a pretty confusing question. And to be honest, if I check this one out, it says that this is the one. Man, textbook answers are really confusing, to be honest. They are like so. Uh, Yo, Horse XD man, how are you doing? What's up, Horse XD? How are you doing? I know I can see you. I'm just looking at this. To be honest, the question answer given in this is a bit too confusing, but I think we can get the idea of what you're doing. Like, you're actually calculating the PN205 with this one. We are preparing for chemistry. Like, I have completed the subject or part portion. We are practicing questions of this last chapter because the questions are of this chapter are really crazy. So yeah, uh, this one is a really good level question. So I'm trying my best to like understand what is going on. Okay, if you don't know, this is the question. The following data were obtained during the first order thermal decomposition of N2O5, where this is the decomposition. 2 moles of N2O5 gives 2 moles of N2O4 plus O2. This is the time, this is the total pressure given data. So we have to calculate the weight constant. And we are using the equilibrium constant that we studied in 11th standard chemistry. And based on that, we can actually add this all and we get the whole value as this much. So we get some equations and we apply some mathematics. But then, we need to get the value of k. So what we do is we apply the first order reaction value here. This is the t. Based on that, we get this. So, and this is pi by pa, which is pretty confusing to be honest. Like, oh my god. Okay, so pa is basically this pn205, but and this is the pi, which is 0.5, and it's already given because that's the initial pressure. That's the total initial pressure. Okay, bro, take care, bro. I'ma go. Good luck, by the way. Yes, thank you very much, Horace XD. Same to you. Yeah, economics exam tomorrow, so all the best for that. Nice to meet you again. It was a great time meeting you. And yeah, let's move on. Everyone is so busy. Like, I know that none of these people will respond to me because in WhatsApp, there are some people who will not respond to me at all. I know that for sure. One minute. So yeah, we're gonna complete this question before we end the stream. That's all I'm gonna say. That's all I'm gonna say, bro. This is gonna be a short stream, not a long one. So, we can try this out. So PN2O5 plus PN2O4 plus PO2. That gives us 0.5 minus 2x plus 2x plus x, which is 0.5 plus x. That is going to give us the value, that is PT is equal to 0.5 plus x. This is the total pressure, initial pressure, but we don't know the value of this pressure because this is that kind of pressure which is formed after some amount of time. So we need to find out this pressure. So in this case, what we're going to do is we already know this one formulated. So what we're going to do exactly is that we need to first of all find out the value of x and then make it directly is equal to pt. So what I can do is PN205 is equal to 0.5 minus 2x, and if I try to calculate it in terms of PN205, we may get values. So PT is equal to no wait, this is PN205, so PN205 plus 0.5 is equal by 2 is equal to x, but so or else no wait, no, we can do what, can substitute this value because it will be much easier. So Pn2O5 is equal to 0.5 plus um, the Pn2O5 should be the initial one, I believe, 0.5. So I can just write 0.5, and here 0.5 minus 2. No, wait, not 0.5 actually, because that will be 0 then. So that's not true. So it should be 0. Something like Pn2O5 respect to that type. So 0.5 minus 2x, and based on that, so p and 2x, so p t 0.5 plus x, so pt minus 0.5, I believe. Okay, 0.5 minus 2 into pt minus 0.5, which is confusing again. I'll try. Pn2O5 is equal to 0.5 minus 2 pt minus 1, I believe. That's going to give us minus 2 pt minus 0.5. I'm now a bit confused because trust me, like, how are we gonna find out p? Okay, wait, pt should be. This is a confusing and tough one. Like, the textbook hasn't given me a great idea of the answer though. Also, I just remembered what the bro was saying. There was one question that bro said, like, what was the what is who has higher electron gain enthalpy, fluorine or chlorine. I remember that it is fluorine, because that is the only highest element, the only element that has the highest electron gain among all, because the Pauling scale gives the measure as, I mean, you cannot measure electron gain enthalpy, but Pauling scale, according to Pauling scale, it is giving it as in the value of 4. So yeah, I do remember that. Anyways, that's another concept I'm worried about. Worried about this one. Like, how is this done? That's what I'm thinking of. So, oh man, I don't know what is actually there, but I'm trying my best, like thinking about what is going on. So wait, so technically, oh, I did not notice that. This is basically Pn2O5 is equal to 0.5. Okay, so then why am I getting this as 1.5? Because that is okay. So 1.5 minus p2 pt. Now, okay, so we got this value. If I do this, then so we're forming equations, I believe. Whoa, bro! Like, oh my god, bro! This is a crazy question I've ever done. So you're telling me Pn2O5 is equal to minus 1.5 at t is equal to 100. Okay, got this one. And this is Pt is equal to how much? It was given as 0.512 according to the question. So 0.512, it's given here. So 1.5 minus 2 pt, that is 2, is equal to 0.512, and Pn2O5 is equal to, I know my handwriting is bad, guys, but let's try to just do it as fast as possible. So 5 and 2, 2, this is 4, this 2, and this is 10, 102, 4, that is 1.024, and we get Pn2O5. Okay, I'm not looking at the textbook, guys. I'm trying to calculate it by myself so that I understand what I'm doing actually. So this is 6, this is 9, this is 7, this is 4, this is 4, and this is 0. So we get 0.476 atm. Next, we need to calculate the weight constant. And to calculate the weight constant, technically we need to use the formula 2.303 by r into log of r naught by r. So this is wait, should we take it for Pn2O5 total pressure? Now that's my doubt. So I have to look at this. Let me just check. So technically it's take the total pressure and then does this. Okay. So 0.5. No, wait. It should be 0.512, then 0.476. Oh my god, I'm so confused, guys. What is this? What is bro even doing here? You're taking 0.5 and not 0.512, and then you say t is equal to 0 seconds. It's one of the most confusing questions I've ever done. Like, bro. What? You telling me that you're using 0.5 ATM, then you use 100 seconds, while here you're saying that t is equal to 0 and this should be 0.5. Whereas if you had used 0.512, you could have used this 100. I am so confused, guys, with this question. Like, let's check. Now, you know what? Let's try. How is it 100 seconds, bro? Okay, this is sensible, 0.476, but out of nowhere you're using 0.5 ATM. 1 minute. Was there anything that we use? Technically PN205 should be 0.5. Should it be 0.5? 1 minute. We never calculated x in this value, but that's one thing. Because basically x is just like a part of concentration where you're just calculating, it's just a number as well, but then it's not given here. This is one of the most thing. This is why I don't like going through the textbook answers, bro. It's so confusing. As okay, wait. Like, bro, what is this? So 0.512 is not the total pressure. Why? Why is it not this? Guys? Okay, wait. I don't know what's going on with this, man. Like, this is a totally insane, bro. What is this? What's wrong with the textbook? Am I doing something wrong, or is it the textbook? I don't know, man. I don't think so. It's 0.5. Okay, you know what? Let me just check. So this is okay. Technically, yes, it should be K. My bad, not R. K. I get it. I made a small mistake. I know, but still, why is it 0. Why is it not 0.512? Like, why? So this is 0.5, and this is like 0.476. But I don't know how it's not like. Yo, what? I'm confused, to be honest. I'm so confused. How could it be? Okay, fine, let's not say that, but how do we know that 0.5 and 0.512 were used as this initial pressure? Like, okay, maybe I got the idea, but then how would we know that which number we should have been choosing here? That is pretty messed up, man. Man, that is 0.0216. Okay, I'll try to calculate from here on. So 2303, 216, 6 3 is 18, 61001, 6 3 is 18, 13, 3032, 006, 064. So 8 1 4 14 7 9 497 448 497 448, man. Okay. 7 1 2 3 4 5 0 point. Good luck again. Thank you very much, man. I know I'm trying to calculate 0.0497 448. Oh my god, bro. Like, what? This is this is really big, to be honest. And this is what I'm getting: 4.98 into 10 raised to minus 4. And this is 10 raised to minus 2. So technically this should be correct. 1 2 So yeah, 4.97 into 10 raised to minus 4. Okay. Man, I swear, bro. Like, what is this question, bro? If this question comes in exam, I'll like, bro, I'm actually shocked with this. Like, how do you even do this? Okay, so you add this up. I got it. I like got the whole context about this. You just take P(N)2O5 out of nowhere. You do this and you get this. Okay, so initial pressure is equal to, let's say initial pressure at T is equal to 0 is 0.5. So that's true. Let's say that you're trying to take a PT, which is PT minus 0.5 though. And then T is equal to 100 seconds, PT is equal to 0.512 atm. Okay. So P initial should be 0.5, but then why cannot be 0.512? That's my doubt. Okay, anyways, you know what? Let's move on because we are wasting so much time in one question. Let's do one last question. This time we're going to do a normal one so that we don't waste more time. Just a normal one. Let's try this. Okay, wait. Maybe I'm not sure about this one, but how? Wait, can we do this? I'm not sure. It's a maximal. Okay, wait. So you're telling me that there is enthalpy. No, this is activation energy. My bad. So EA is equal to 209.5 kilojoule per mole, and here activation energy for this reaction, if this is taking place on a gold surface, then I would say yeah. Also the temperature is given, so it's gonna be easier for me. 581 Kelvin. Nice. R is 8.314. That is much greater again. I don't know about the value of A though. What's the value of A in this? No, wait, we're not gonna do that, aren't we? Huh. Okay. So calculate the fraction of moles of reactants from having energy equal to or greater than activation energy. So if you try to draw the graph, can we get any context about this? 1 minute. Let me just draw a graph and check. So we know that this is gonna be the graph, and by looking at this, this is this is HP, this is HR. Finding the difference from this, we'll get delta HR, delta H. And this is full activation energy. This activation energy is 209.5 kilojoule. This is progress of reaction on this direction, and this is EP, potential energy on this one. So can we apply this formula? Let me just check. So wait, not sorry, this is not the one I'm looking for, my bad. This is the wrong graph. Maximal Boltzmann curve, my bad. So EK, this one, and this one, fraction of molecules. Let me check. If we can try, we can. So it's like something like this, and then you get some kind of graph like this. This is Maxwell Boltzmann curve. Energy equal or greater than activation. So wait, let's check the context of this if we can get some ideas. So this is activation energy, let's say, where this will happen, and then area shows molecules of fractional molecules reacting at T. 1 minute. So this should be at T, right? So okay, this is calculate the fraction of molecules of energy having equal or greater than activation energy. Maybe this is the region we may need to calculate. Okay, so this is the one. I'm not sure how you do this one though. Okay, interesting. So you're like taking the area of this graph and maybe finding it out, but that's not going to give us the fraction of molecules, right? That's one thing about it. So yeah, it's like having it. But can you check this out? 1 minute. Let's say I take this much portion, small amount of this, but then I don't have, I have activation energy as this. Can I like apply integration here? Because this is like under the curve and this starts from here. This is like, let's say 209.5, 581, but that's not the temp. Okay, so you know what? Let's just end the stream from here because I feel like um, it's not because I cannot solve a question, it's because it's getting too late. Like just forgot about my time. I have to sleep also. So yeah, I'm gonna end the stream right now, and I'm sorry, I didn't complete this question, but yes, we did complete the previous one, but it's really confusing, so I have to check that one still. So for now, I'm gonna end it, and hope you guys have a great time. Bye. See you next time. Allah Hafiz. Meet you tomorrow, guys.